This is going to be on RT-PCR and COVID-19 for GMS 6552. In March of 2020, the world was hit with the start of a deadly pandemic with a continuous impact years later. At the start of the pandemic, the U.S. saw a variety of mitigation regulations to cease the spread of the disease, such as face mask wearing. However, what was really needed was a testing measure accurate enough to provide assurance to those in need. On February 3, 2020, the U.S. government submitted plans to expedite the development of a test to detect the COVID-19 virus. Though unreliable at first, the first COVID-19 test was released to healthcare laboratory officials in NYC on February 5, 2020. This test used RT-PCR methods in its mechanism of detection. RT-PCR is a method of viral detection that has been used in the clinical setting for decades. So let's start with the basics. DNA is the genetic makeup of your body. It is the traditional double strand or helix that you have probably seen before in science class. And DNA is like a blueprint telling your body exactly how to function and what to do. Segments of DNA are called genes, which provide information regarding your distinct physical characteristics. And everyone has their own unique DNA sequence, which is what sets us apart from one another. Besides DNA, another important factor is RNA. Unlike DNA, RNA is just a single strand or one helix. When you think of DNA as a blueprint, think of RNA as the planners, executing all of the information regarding the decisions of the function of the human body. RNA and DNA play a pivotal role in human life and can convert between each other to execute tasks like the conduction of RT-PCR, and this is done with the help of enzymes, which are just little helpers throughout the body to ensure the timely completion of the task itself. Now, on to COVID-19. COVID-19 is a virus containing an RNA and protein center surrounded by a protective membrane, kind of like items within a safe. Though the RNA within the COVID-19 virus is the SARS-2 genome, it provides instructions for the replication of the virus within the body. And with that, the virus is free to spread throughout the body, initiating the onset of the disease itself. So how does this relate to COVID-19 testing? Upon swabbing your nose or mouth, scientists are able to provide an immense amount of information regarding your health, one being the presence of COVID-19. RT-PCR test first starts by extracting genetic materials from the swab. Next, COVID-19, since it's RNA and RNA virus, that's what they need, the genetic material. DNA is what's gathered from the swab, but is quickly converted into RNA through the use of reverse transcription, led by the enzyme reverse transcriptase. This new DNA is called cDNA because it's complementary to the original RNA strand. Following this, RT-PCR works through the completion of 3 steps: denaturization, annihilation, and elongation. The sequence coined amplification is done multiple times. The first step is denaturization, in which DNA is desequenced and broken. Next comes annihilation, which RNA primers go through the denaturized DNA strands to find copies. When bound to the complementary DNA, this starts the final step of elongation, in which Taq, another enzyme, is used. Again, this process is completed 30 to 40 times to ensure billions of DNA copies are present for viral detection. This sequence is completed with the use of a PCR thermocycler machine. And with the newly made DNA sequences, they use fluorescence, which tracks how many copies of the virus has been made. In other words, replication of the sequence was only completed by those with the viral DNA. By using the fluorescent dye, scientists can see how much viral DNA is within the body. And this is done in real time, meaning that scientists are able to see their results as it is being completed and multiplied. It's going to be an exponential line if the virus is present, and more of a linear if it's negative. Overall, there are many advantages to RT-PCR, with the main being timely results and low potential for false positive results. However, it has been shown that there are a higher chance of false negatives, resulting in the need for continued development of testing measures. Finally, though the COVID-19 vaccine is available worldwide, the need for testing continues to be warranted as it is the best way to understand the spread of the virus itself.